Okay, so let's say that I want to draw the Lewis dot structure for CCl4. So this is 1 carbon atom and 4 chlorine atoms. So usually for Lewis dot structures, you want to find your central atom. It's usually going to be the first one. Or you'll grow into this, but you'll see that if there's 4 of this one and 1 of this one, this is probably the middle. So I'm going to draw carbon in the middle, draw a little skeleton, and I need to draw 4 chlorine atoms around it. I'm just going to spread them out like this. Chlorine, chlorine, chlorine. Alright, so now I need to draw a skeleton. I'm almost there. I'm going to connect all of these with 1 single bond. Remember, 1 single bond stands for 2 shared electrons. So there's actually 2, 4, 6, 8 electrons here. Because there's 8 electrons around carbon, carbon is happy. Okay, so now that I drew my skeleton, I'm going to want to find the number of valence electrons that are in this total compound. So carbon is in group 4A. Because it's in group 4A, it's going to have 4 valence electrons. So carbon has 4 valence electrons. Chlorine is in group 7A, so it has 7 valence electrons. So 7. However, there are 4 chlorines, so I have to multiply this number by 4. And now I have to add them. So 4 plus, let me move it over a little bit. There it goes. So you got 4 plus 7 times 4 is 28. 4 plus 28 is 32. So I have to work with a total of 32 valence electrons. 32. Alright, so because I drew my skeleton, I already have 8 valence electrons drawn. 1, 2, 3, 4, 5, 6, 7, 8. Right? Each single bond represents 2 shared electrons. So now I have 8, I need to get to 32. So I'm going to start putting them. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. And that is my Lewis dot structure for this compound. Okay, so we are going to move on to do a different example. Let's do NH3 this time. NH3. So the first atom is usually my central atom. I can see that there's 1 of this one and 3 of these ones. So this one is probably surrounded by everything else. So I'm going to draw nitrogen in the middle. And I have 3 hydrogens around it. So I'm going to say hydrogen here, a hydrogen here, and a hydrogen here. I need to draw my skeleton, so I'm going to connect all of these atoms with lines. Remember, each line represents 2 valence electrons. And now I'm going to find the total number of valence electrons for this compound. So nitrogen is in group 5A, so it has 5 valence electrons. And hydrogen is in group 1, so it has 1 valence electron. However, I have 3 hydrogens, so I have to multiply this number by 3. So now I have 5 plus 1 times 3 is 3. I have a total of 8 valence electrons I need to deal with. I already have 2, 4, 6 drawn. I need to place 2 more. Hydrogens is my exception that they can only hold 2 electrons, and they each already have 2 electrons because they have 1, 2 shared right here, 1, 2 shared right here, so this hydrogen is happy, 1, 2 shared right here, so this hydrogen is happy. The only other place that I can put my 2 valence electrons that I have left is on nitrogen. 1, 2. And that is because nitrogen had 2, 4, 6. It needed 2 more to be happy, so 7, 8. And that is my Lewis dot structure for NH3. Okay, next example. Let's say I want to do a Lewis dot structure for NBr3. The first element is usually my central atom. There's 3 of this one, 1 of this one. So this one is probably in the middle. So I'm going to draw N in the middle. And then I'm going to spread out my BRs. So I'm going to do a BR right here, I'll do a BR right here, and I'll do a BR right here. I'm going to draw my skeleton, fill them in, connect them with lines. All right, now I'm going to find out the number of valence electrons in this compound. So nitrogen is in group 5A, so it has 5 valence electrons. And bromine is in group 7A right here, so it has 7 valence electrons. However, I have 3 bromine atoms, so I have to multiply this number by 3. And now I add the total. So 5 plus 7 times 3 is 21. 21 plus 5 is 26. So I have 26 valence electrons I need to deal with. I already drew 2, 4, 6. So let's draw them around my bromines that really do need valence electrons because they're not happy right now. They only have 2. So I have 2, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So I filled out each one. I'm at 24. The only other place I can put valence electrons is in my central atom that only has 6. So 24, 25, 26. Reach 26 valence electrons. Every single atom has a total of 8 valence electrons. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 7, 8. And that is my Lewis dot structure for NBr3. So now let's do my last example. This one is actually going to be an ion. So we're going to do the Lewis dot structure for NO3 minus. Okay, so N is probably in the middle because it's my first atom and it's surrounded by 3 oxygens. So I'm going to draw N in the middle. And then I'm going to spread out my oxygens. And then I'm going to fill in the skeleton. Draw those lines. Okay, now I need to calculate the number of valence electrons. So nitrogen is in group 5A. So nitrogen has 5 valence electrons. Oxygen is in group 6A, so it has 6 valence electrons. However, I have 3 oxygen atoms, so I have to multiply this number by 3. Okay, so let's figure this out. So I have 5 plus 6 times 3 is 18. 18 plus 5 is 19, 20, 21, 22, 23, right? 18, 19, 20, 21, yeah, 23. So I have 23 valence electrons, but I am not done yet. This is an ion. It has an extra valence electron. It is a charge of -1. That means it has 1 extra electron. So I have to add 1 extra valence electron to a total of 24 valence electron. And this is what I have to put in my Lewis dot structure. So I have 2, 4, 6 right now. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and 24. Okay, so when you look at this, my oxygens all have a total of 8 valence electrons. They have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. My central atom only has 6. 2, 4, 6. My central atom is not happy with me because I did not give it 8 valence electrons. So one of these oxygens is going to have to share one of their 2 electrons and to draw a line like this. So now my central atom nitrogen has 2, 4, 6, 8. It's happy. This oxygen has 2, 4, 5, 6, 7, 8. Now everyone is happy. I'm almost done. Because this is an ion, I have to put the whole thing in brackets and put my charge in the top right hand corner. And that is my Lewis dot structure for NO3 -1.